this problem, we have the integral from 1/5 to 3/5 of inverse tangent square root of 5x divided by 5x to the half plus 5x to the 3/2. Okay, so what we're going to do in this problem is a U substitution. You get U is equal to inverse tangent of the square root of 5x, which means we need to figure out what du is. Okay, so to figure out what the derivative of tangent inverse of square root of 5x is, let's go to the formula. So when u is a function, then the derivative of tangent inverse of u, where u is a function, is 1 over 1 plus u squared du, where du is the derivative of whatever the inside function is. So we're trying to figure out what is the derivative of this. Okay, so our u is going to be the square root of 5x. Okay, so this is going to be equal to 1 over 1 plus square root of 5x squared, right? Okay, and then times the derivative of the square root of 5x. Okay, so we need to figure out what the derivative of the square root of 5x, so we'll know what to multiply. So let's go down here and talk about the derivative of 5x, then we'll come back to that. So the derivative of square root of 5x, we could write that as 5x to the 1/2 power. So it'll be d over dx times 5x to the 1/2 power. Okay, so this is going to be a product rule. So you bring down the half, and then you rewrite the inside, and then you take a derivative of the inside. Okay, so that'll be 1/2 times 5x, and you subtract the exponent. You subtract 1 from this exponent, which will make it -1/2. Okay, and then the derivative of the inside, the derivative of 5x, is 5. Okay, so since this is a -1/2, it's going to have to go down to the bottom. Okay, so this will become 1, actually 5. 5 is the only thing that's going to be on top. 5 on top. The 2 goes down, and then the 5x to the positive 1/2 goes on bottom. So times 5x to the 1/2. Okay, so that is the derivative of the square root of 5x. And you could also write this as the square root of 5x on bottom if you wanted. Okay, so let's rewrite. Let's go back up here and write it all together. So that gives me 1 over 1 plus. Let's square this. Square root becomes 5x times, instead of d over dx is square root of 5x, we'll write this answer. So times 5 over 2 times 5x to the half. Okay, now if I multiply that through, I'm running out of paper here, so let me get a new piece of paper here. If I multiply that through in the denominator, or well, and the numerator stays as a 5. Okay, the denominator, I will be multiplying 2 times square, or 5x to the half, all times 1 plus 5x. Okay, now I'm going to leave the 2 out front, but I am going to distribute this 5x. Okay, so it becomes 5 over 2. And if I distribute this 5x to the half to this 1, that gives me just 5x to the half. Okay, and if I distribute the 5x to the half to the 5x, okay, this is 5x to the power of 1. You remember, you add exponents, so 1 plus a half is 3/2. So plus 5x to the 3/2. Okay, so that will be the derivative. This whole thing here will be the derivative that we were looking for of the tangent inverse of the square root of 5x. So let me write that down. It will be 5 over 2, put a little bracket there, 5x to the half plus 5x to the 3/2. Okay, so we've got our derivative of inverse tangent of square root of 5x. Okay, so now we can rewrite this problem. Okay, I'll take care of the limits in a second. Let me rewrite the problem. I'll leave the limits off, but we are going to have to change our limits. But this tangent inverse of 5x is our u. So there's my u. Okay, and then I've got, oh, I forgot to put my dx over here. Okay, and then I've got 5x to the 1/2 plus 5x to the 3/2. That was what was already in the denominator, right? Okay, now if I want to substitute for my dx, I need to multiply this stuff over and divide by the 5. So my dx is going to be equal to, the denominator goes to the top and the numerator goes to the bottom. So 2 times 5x to the 1/2 plus 5x to the 3/2, all divided by 5 du. Okay, so notice how that's going to help us here because it's the same stuff here, right? So it will cancel out. Okay, it will reduce. Okay, so let's multiply by 2 times 5x to the 1/2 plus 5x to the 3/2 divided by 5. Okay, so conveniently, this whole thing is going to cancel out, and you're going to end up with 2u over 5. 2u over 5 du. Okay, now let's figure out what our limits are because we didn't do that a second ago. So let's go back to the tangent. Okay, so u is equal to tangent inverse of the square root of 5x. Okay, so if we plug in our lower limit there, it'll be u is equal to tangent inverse of, let's see, plug in the fifth, square root of 5 times 1/5. Okay, so that's going to be the square root of 1. So it's going to be equal to the tangent inverse of 1, which is going to be 45 degrees or pi over 4. Pi over 4 would be the lower limit. Okay, let's plug in the top one now. So tangent inverse square root of 5 times 3/5. Okay, so that ends up being tangent inverse of the square root of 3. Okay, and where is tangent inverse equal to the square root of 3? Let's see, so this would be pi over 3. Okay, so that's where tangent is equal to the square root of 3. So that's our upper limit. So we have pi over 4 to pi over 3. Okay, so we take the integral of this. So this becomes, let's see, 2u to the 2 over 2 times 5 from pi over 4 to pi over 3. Okay, so this is equal to, let's see, the 2's cancel out, u squared over 5 from pi over 4 to pi over 3. So that becomes pi over 3 squared over 5 minus pi over 4 squared over 5. Okay, so let's see, that will give us pi squared over, let's see, this will become a 9. And then we multiply that by 5 because you flip this one up. You flip these up and multiply. So square the 3, you get a 9 times 5 is 45. And square the 4, you get 16. 16 times 5 is 80. So minus pi squared over 80. Okay. And if you bring those together, to make it quicker, you might want to grab a calculator. Subtract 1 over 45 minus 1 over 80, and then bring in the pi squared. That's going to be equal to 7 pi squared over 720.